This video demonstrates how to modify vectors. We're going to write a program that encrypts any message. And the encryption scheme is to reverse the letters of the alphabet. So A will become Z, and Z will become A. B would become Y, Y would become B, etc. And so what we're going to do is use two vectors of characters. The first vector will be our normal character, our normal letter, like A, B, C, etc. And then our second vector will be the encrypted character, which would be Z, Y, etc. And these vectors will be size 26 because there's 26 letters in the English alphabet. So let's start with an n of 26, and we need two vectors of characters. And the first will be called norm or normal, and it will be size 26. And we'll have a second, which will be our encrypted version, and that'll also be size 26. So what we want to do here is we want the location 0 of normal to be A, and normal at 1 to be B, etc. We want that to keep on going, which sounds terribly painful to do. And then similarly, we want encryption at 0 to be Z. We want encryption at 1 to be Y, etc. We want to do that another 24 times. So instead of having to type this all out, an easier way is to use a loop, and we will fill up the vectors with a loop. And we're going to be inputting into each of the locations the ASCII number that is the representation of the character we're intending to get. So let's just do an example. So if we output Z, let's see, we have, and we'll convert Z, we'll static cast Z to be an int. So we can see what the value, the ASCII value of Z is. It's 122. And then if we were to subtract that by 1, we'd get 121. But what is 121? If we made this into a char, it would be Y. So we can keep on subtracting, and if we subtracted by 2, it would be an X. And if we subtracted by 3, it'd be a W. Similarly, we could start with an A, and we get the ASCII character of A, which is 97. And if we were to add it plus 1, then it would be a B, plus 2 would be a C. And we can show that by storing this value inside of a char. So I'm just going to create a char called test, and I'll initialize it to just a dash, and then we'll change test to be the char A plus 1. And let's output test. And then we have a B. And if I do a plus 2, compile, we get a C. All right, so how can we utilize this? Let's make a for loop, and we'll cover all the letters of the alphabet. And we'll output each of those letters of the alphabet inside the for loop. So I'm going to both convert and output. So let's add I instead of a integer literal. So we'll first add 0, and then we'll add all the way up to 25, and then we'll output that value with our test character. And I was not declared. There we declared I, recompile, and there we have A through Z in a for loop. And what we're really wanting this is to store this into normal. So we'll just store normal at location I, and then we can output normal. So we don't actually use test anymore. Let's get rid of test. And there we go. A through Z is being stored into normal. We'll do the reverse method for encryption. So we'll encrypt at I, but instead of starting at A and adding I, we'll start at Z and subtract I, and that will give us encrypt. So let's show what this will look like. We'll have normal, we'll convert into, so I'm just adding this arrow like we did up in the comments. And then we'll have encrypt at I, so that'll be our output statement. Let's see if we did this correctly. A goes to Z, and then we went, and this is completely the wrong output. What happened? What happened is, instead of subtracting from Z, we're adding to Z. So we're going beyond the alphabet, and we're getting all sorts of weird characters. So we're supposed to subtract by I. Now let's compile, and here we go, A to Z through Z to A. So there we have our encryption scheme all set up. So we can get rid of this code, which is just for testing purposes. Now we know we correctly have our normal character and encryption character. And so the next step is we need to get a message, and we can encrypt that message. So let's make a message. We'll call this to_encrypt, and we'll make this message be our secret message. Okay. And we're going to, of course, if we're going to have a message to encrypt, we need to have the encrypted, which we don't know what that is going to be yet. So how are we going to do this encryption? What we're going to do is take the normal character, find it inside of the encrypted message, and then replace it with the encrypted character, and we'll do that replacement inside the encrypted message. So we're going to start with the encrypted is equal to encrypt. Okay, good. And let's first check if we can find a specific character. Let's say we can find A. If we find A in our message, and there is an A in the message, then the find function returns the location inside of the string of A. So let's take a look what that looks like. 11, location 11. So at location 11 is A. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There we go. Location 11 is the A. So it found the A. Okay, let's make a variable called location so we can store that location. And we can use that. Location is the found character inside of it encrypt, inside of the string to encrypt. And I'm going to just output location to verify everything's still working. And that seems fine. So encrypting, we're finding A. Now if we looked inside of the to encrypt message at location of what was found, we can verify that it found an A. And there we go. It did find the A. Found that correctly. So what would we want done when it found an A? What we'll do is we'll blank out by replacing this location in the to encrypt with a hyphen. And we're going to do that so that we don't find that A anymore. That A is no longer going to be found because we have a hyphen. And so we're replacing the A with a dash. So let's do that with to encrypt. Now we can take a look at what the message to encrypt looks like once we do this replacement. And we actually just replace the A with a dash. We found the A, we replace it with the dash, and then we output the to encrypt message. Now what about the message that's supposed to be encrypted? Well, the encrypted message starts out as the message to be encrypted. And what do we want to do? We want to replace the A with a Z. So at the same location, we want to replace with a Z. So let's take a look at what the encrypted message looks like. Compile, execute. Our encrypted message now has a Z at the location where there used to be an A. And we've dashed out the to encrypt message. Okay, so that's a good start. Now all we have to do is get rid of all the A's. So let's make a secret message with a few A's in it. We'll say a secret message. Let's go ahead and rerun our program. And it replaced the first A with the hyphen for the to encrypt and a Z in the encrypted message. But there's another A. So what we'll do is we'll just make a while loop, and while the location is not -1, we'll keep on doing this process. Okay, and at the end of the while loop, all we need to do is look for the next location. Is there another A? If there is, then the while loop will be true, and we'll replace the next A with a hyphen and a Z in the encrypted message. So let's compile and take a look. So in the first iteration of our while loop, we got rid of the first A and replaced it with a Z. In the second iteration, we got rid of the second A and replaced it with a Z. So we're doing real well so far. I'm going to move these cout statements outside the while loop so we don't get so much output. Next, what we can do is replace each of the letters. Now this A is really just from normal at location 0. And this Z is really just encrypt at location 0. And once again, we have a find at the end of the while loop, and that A is just normal at location 0. So let's verify we're still working. Our program's still working. We've replaced the A's with a dash, and in the encrypted message, we replace them with Z's. So we're doing well so far. Now what do? Well, we can use a for loop and iterate for each of the indexes in normal. Instead of just at index location 0, we can do location 1, 2, all the way to n-1. Same with the encryption vector. So let's copy the for loop. We'll paste. We'll indent the inside contents and close the for loop. And then we can replace the toEncrypt find with an I, the encrypt at with an I, and the normal with an I. So that's just replacing those zeros. Instead of just looking for A and converting it to a Z, we'll do that for the first iteration. For the second iteration, we'll look for all the B's and replace them with Y's. In the third iteration, we'll find all the C's and replace them with X's, etc. So let's take a look now at what the program looks like. So now we have an encrypted message, fully encrypted. Cool, thank you.